In this example, we're going to evaluate the integral of tangent to the fifth power of x times secant to the third power of x dx. As with other trigonometric integrals, we know that we need to make smart choice for substitution. When we start, we may not know what kind of substitution to do, but we're going to try different options. So here, since I have tangent and secant, well, I'll try option 1, letting u be equal tangent of x, and then option 2, I will see what happens if I let u be equal secant of x. Okay, so let's start with option number 1. If u is tangent of x, then what is du? Well, derivative of tangent is secant squared of x dx. So what that means? It means that to introduce u, or to replace everything by u, first of all, tangent will be replaced by u according to my substitution, right? So it's going to be u to the fifth power. And I will need to obtain secant squared of x dx. Well, I can find secant squared of x dx in here, right? If I separate and set aside secant squared of x from the cube. So I'm going to write this down. Tangent to the fifth power of x. And then I'm setting aside secant squared, so I can try to introduce differential du. That means that secant cubed will now be written as secant of x times secant squared of x dx. Together they make cube, the original cube, right? Okay, I'll make notes for myself as far as what kind of substitution I have here. So tangent I'm replacing by u. It's going to be u to the fifth power. And now this part, secant squared of x dx, is going to be du according to my substitution. And now I'm left with this piece, with this factor, which is just secant of x. Now, if I can replace secant of x with tangent of x, then I'm good. Then I can replace everything with u. But can I do that? Well, at this point, I have to refresh what kind of identities I can use. Identities that connect secant and tangent. And the one that we usually use to relate secant and tangent is the following. Secant squared of x, well, since I have secant here, I'm going to start with secant. Secant squared of x equals 1 plus tangent squared of x. But now, similar to sine and cosine identities, or basic identities, identity that relates secant and tangent and involves squares, right? So both secant is to the second power and tangent to the second power. So in order for me to use this identity to go from secant to tangent or from tangent to secant, I had to have that be raised to even power. So power 2 is perfect. If it's power 4, I can deal with that. I can rewrite it as the power of 2. And so on and so forth. But if it's an odd power, well, looks like there's nothing I can do. So from what I can see right now, that option does not work. Let's try option number 2. Okay, what if u is secant of x? Then du is secant x tangent x dx, right? Derivative of secant is secant tangent. Okay, so introduce variable u in this case. I have to set aside secant and one tangent, one factor of secant, one factor of tangent. Let's see if I can, if that's possible. So I will be rewriting my integral, but I will be setting aside one tangent and one secant. So that means that I will have tangent to the fourth power. I'll set them aside at the end. Tangent to the fourth power. Next, that will be secant to the second power. And here they are, those single factors, secant x tangent x dx. Now I will double check. So tangent to the fourth power times tangent gives me the fifth power. Well, here it is in my original integral. And then secant squared times secant gives me secant cubed. Well, here it is. Okay, so it means that I am looking at my original integral. I just manipulated it a little bit. Now, let's try substitution. So we're saying that u is secant of x. Okay, it means that that's my u. So it's going to be u to the second power. Now, du is secant tangent dx. Secant tangent dx is over here. Okay, that's du. Now, the remaining portion, the remaining factor here is tangent to the fourth power of x. If I'm able to replace it with secant, then I'm good. That's how I can connect it to u. But can I replace tangent to the fourth power of x with expression involving secant? Well, actually we can, right? That's the case where power is even, and we should be able to use an identity. Now, that's going to be same identity, even though I want to rewrite it, right? Since I'm replacing tangent, I want to have tangent by itself in this identity. So to get it by itself, I just simply have to subtract 1 from each side. So that means that tangent squared of x equals secant squared of x minus 1, right? So, okay, that's what we're going to use. But the only thing that I don't have tangent to the second power, I have tangent to the fourth power. Well, that's totally fine, because tangent to the fourth power I can write as tangent squared of x and then squared again. That makes the fourth power, right? And this tangent here, I will replace by secant squared of x minus 1 from my identity. Secant squared of x minus 1. Well, since tangent squared was squared, it means that this expression has to be squared, right? So that second power is over here, and that is tangent squared. Now I'll put this all together. Oh, and then, by the way, here's u, right? That's going to be u. Now I have everything in terms of u. That's how my integral is going to look like. It's going to be integral. Now here I have this expression, u to the second power minus 1, square outside. Secant is u, but since secant is squared, it's going to be u squared. And then all that is du. Perfect. So that means that second option did work. In the textbooks or other resources, you can find kind of like rules to remember. Okay, if power is odd or even, you do this or that, or this kind of substitution or that kind of substitution. For me, it's just easier to try that rather than memorizing those rules. Let's continue with this integral and evaluate it. Now I have algebraic expression here. I have binomial squared and then multiplied by this u squared. So to integrate this, I have first to perform algebraic simplification, right? I have to perform those operations. First, I'm going to square u squared minus 1. So that's u squared minus 1 times u squared minus 1. And that is u squared times u squared is u to the fourth power. U squared times negative 1 is negative u squared. But I'm going to have another negative u squared. So it's minus 2 u squared. And then negative 1 times negative 1 is plus 1. And then I still have u squared outside. And now I will have to distribute like that. So my expression is u to the sixth power. Remember, when I multiply, I have to add powers. U to the sixth power minus 2u to the fourth power plus u squared du. And that is a polynomial that I can easily integrate. U to the seventh power over 7 minus 2u to the fifth power over 5 plus u cubed over 3 plus c. Okay, and the last step is to return to the original variable of integration, which is x. We're going to do that by refreshing what kind of substitution we performed and what u equals to. Well, u equals secant of right here, secant of x, which means that every u in my answer I will replace with secant. Secant to the 7th power of x over 7 minus 2 secant to the 5th power of x over 5 plus secant cubed of x over 3 plus c. Here it is. That's the answer. So when you have integrals, trigonometric intervals with tangent and secant, or it could be cotangent and cosecant, same idea. Well, try options, see which one works. Just be careful with finding derivatives, right? So with sine and cosine, it's a little bit easier to remember them, but just be careful, writing correct derivative for tangent or correct derivative for secant, right? And make sure that you set aside whatever you need here. So set aside this or secant tangent so that you can introduce the differential du. Now, it didn't work in the first case, it did work in the second case.